Hey math kids, today we're going to go over something called L'Hopital's rule, and it's for limits when we encounter any of these three situations. So if we have 0 divided by 0, infinity over infinity, or 0 times infinity. So we're going to look at this, and I'll just kind of introduce the rule to you as we do it. So this first one is going to be a 0 over 0 rule. And what we need to do is we need to take the derivative of, not the derivative, we need to take the limit of the top with respect to, or as x approaches 0, and then the limit to the bottom to see if it's 0 divided by 0. So if we plug in a 0 to the top, we get 2 to the 0 minus 1, which is going to be 1 minus 1, which is 0. So the top limit would be 0. Then if we plugged in 0 to the bottom, that's obvious that that's also 0. So we have our 0 over 0. Now, what L'Hopital's rule says in this case is that now if we take the derivative of the top and the derivative of the bottom and take the limit as x approaches 0 of both of those, then the overall limit will be the limit to this. So that was probably confusing how I said that. But what we're going to do, take the derivative of the top. So the derivative of the top is going to be 2 to the x natural log of 2, and then this just goes to 0. And then the derivative of the bottom is just 1. So now the 0 doesn't matter. 1 on the bottom of a fraction doesn't matter. Well, actually, let me be a little more explicit. So the limit as x approaches 0 of the bottom, limit as x approaches 0 of the top. The limit, so any limit of a constant is just that constant, so that doesn't matter. And then if we divide anything by 1, that doesn't matter. So we're really just looking at the limit of the top right here. So we're going to plug in a 0 for the 2. Natural log of 2, that's really just a 1 natural log of 2. So that's natural log of 2. And so the original limit that they asked us for is equal to natural log of 2. Alright, this next one, we're going to get the limit as x approaches infinity of x e to the negative x. For this one, if we plug in infinity for x, it's going to be infinity. If we plug in infinity to this, remember this is the same thing as saying 1 over e to the x. And so if this gets really big, it's going to make the bottom of this fraction really big. And if we do 1 divided by something really big, it's getting closer and closer and closer to 0. And so we actually have this situation this time. Now, if we have that situation, then we want to convert to infinity over infinity form, is what it's called. And so to do that, we take our thing that went to infinity, which was x, keep that on top, and then the thing that went to 0, we put that on the bottom. Okay. And so this, we could view it as infinity over infinity, because e to the infinity is just going to blow up and go to infinity. Okay, now we need to take the derivative of the top and the bottom. And so the derivative of the top is just 1. Derivative of the bottom is e to the x. And so we take the limit as x, the original limit of each of them. So the limit as x approaches infinity, limit as x approaches infinity. Once again, it's a constant. That doesn't really matter, so that just stays 1. And then this is going to blow up to infinity if we plug that in. 1 over a really, really large number is going to approach 0. And so that is the limit of our original thing written in yellow. Okay, and then we're going to do the limit as x approaches infinity of natural log x over x. If we plug in infinity here, it's going to go to infinity. If we plug in infinity here, it also goes to infinity. So we have infinity over infinity. So we need to take the derivative of both of these. The derivative of natural log of x is 1 over x. Derivative of x is 1. And we look at that as the limit as x approaches infinity individually. Limit of a constant is just that constant. 1 on the bottom of a fraction doesn't matter. And so if we just plug in infinity to this, we're going to get 1 over a really large number, which approaches 0.